Welcome to this video on the topic of Year 8 Mathematics, Building Algebraic Expressions. In this lesson you'll learn how the order of operations applies to algebraic expressions. An expression is a mathematical statement that does not have an equal sign. Expressions are constructed, or in other words built, using the BEDMAS order of operations. In contrast, expressions are deconstructed using the reverse BEDMAS order of operations. The BEDMAS order of operations is shown over here. It shows us what order we carry out the operations to simplify a statement. So we have brackets, which is the most important, exponents, which is the second most, division and multiplication, which is the third most. We can do these in either order. And then addition and subtraction, which is the fourth most important. Again, addition and subtraction can be done in either order. The construction and destruction of expressions may be shown using diagrams. Let's have a look by example. Example 1, draw the flowcharts that show how the following expressions are built and deconstructed. We have the expression 3x plus 2. What we want to do is we want to build a flowchart that shows how the expression 3x plus 2 is built, starting from x. To begin, let's study the expression. We have 3x's, and then we have a plus 2. The first question we're going to ask is, what operations are present here? The most pressing one that we see is there's addition because we have a plus. On to the x, we're plussing 2. The second operation that we see here is there's a 3 on the x, which implies we're multiplying x by 3. Okay, these are our two operations that have been implied. Next, we need to understand which one comes first and which ones come second. Now, going up to our BEDMAS chart, we know that addition and subtraction come last, division and multiplication come after exponents but before addition and subtraction. So looking at this, we know that addition and subtraction is going to be the second one. Multiplication by 3 is going to be the first. So remember, multiplication is above addition. So first, then second. Okay, we understand what is going on in our expression, and we understand the order in which the operations apply. Let's draw a flowchart that shows how this expression is built. Starting off, I'm going to draw a box and I'm going to put my x inside the box. This implies that we're starting off by building our expression up from x. Next, I'm going to put a box to the right, and then I'm going to show that my x is going to become 3x. And then finally, my expression is going to become 3x plus 2. Now, looking at how this was constructed, to go from x to 3x, we have to multiply by 3, as shown by the instruction over here. To go from 3x to 3x plus 2, we have to add 2. And thus, we've drawn a diagram that shows the construction of the expression 3x plus 2. Now, let's have a look at how we can destruct it. To destruct this statement, we do the opposite of what our arrows are showing. So rather than plussing 2, what we're going to do is we're going to draw an arrow that points in the opposite direction. And to go from 3x plus 2 to 3x, we don't plus 2, we take 2. Similarly, to go from 3x to just x, rather than timesing by 3, we divide by 3. And therefore, we've constructed a flowchart that shows the construction and destruction of the expression 3x plus 2. Alright, next one. Something that looks a little bit trickier. We have the expression 5 take 2y. Now, comparing the two, have a look. Rather than a variable of x, we have a variable of y. Rather than the x being the first in the expression, it's now the second. And in addition to that, it's got a negative in front of the y. It's got a 2 and then a negative in front of that. This expression is not so easy to work with, so what we're going to do is we're going to modify it. Rather than being 5 minus 2y, what we're going to do is we're going to reverse the order. And we're going to change it to minus 2y plus 5. Because remember, there's a plus in front of this 5 here, we just don't have to show it. And the order in which we arrange our terms doesn't matter. So now all of a sudden, this expression here looks similar to this expression here. Now, let's look for the operations that are at play. First one we can see is there's addition. And we see that there's multiplication by minus 2. The order in which this is done, remember, multiplication comes first, addition comes second. Let's build the flowchart. Starting off, I draw my starting variable, which is going to be y. Next, I'm going to do my multiplication, which is by negative 2, so y turns into minus 2y. And then finally, my minus 2y is going to turn into minus 2y plus 5, which is the same as saying 5 take 2y, which is what we have originally over here. Putting this together, my construction is first I multiply by negative 2, and then I add 5. After this, to build a destruction, rather than adding 5, I take 5. Rather than timesing by minus 2, I divide by minus 2. So you can see, starting from y, I times by negative 2 and it becomes negative 2y. I add 5 and it becomes 5 take 2y. Destructing this, 5 take 2y becomes minus 2y by simply taking this 5 away. Minus 2y becomes y by dividing this statement over here by minus 2. So the minus 2 turns into a 1, so you get 1y. Therefore, we see the creation of our construction and destruction flowchart. Okay, let's up the ante. Fractions. Example 2. Draw the diagram that shows how the following expressions are built. Our expressions are 4b minus 7 all divided by 3. Now, having a look at how this is built, we have a subtraction of 7, a multiplication by 4, and a division by 3, or negative 3 actually. Understanding the order of operations here. We have multiplication, we have division, and then we have subtraction. Now, because this is a fraction, we have to take into account that there's implied brackets here. The numerator of a fraction is always in brackets. So what this implies is that, firstly, the multiplication and the subtraction have to occur first, and then finally the division can occur last when we're evaluating this. Why? Because we do our brackets first, then inside the brackets we have addition, inside the brackets we have subtraction, and we have multiplication. So the order in which this is going to occur is, firstly, multiplication, subtraction, and then finally this division here. Going down, let's set ourselves up. We're working with the variable b. First thing that's going to happen is b is going to become 4b. This will occur because we're multiplying by 4. Next, 4b is going to become 4b take 7. This is going to happen because we take 7 away. And then finally, 4b take 7 is going to become 4b take 7 all over negative 3. This is going to occur because we divide by negative 3. Thus, the construction of our chart is done. Looking at the destruction of this expression, rather than dividing, we times, and we times it by minus 3. Rather than adding or taking 7, we add 7, and rather than timesing by 4, we divide by 4. And thus we have completed the flowchart that shows the construction and destruction of the expression 4b take 7 divided by negative 3. Okay, let's keep going. We turn our attention to 1 minus 3u all over 5. Now recall that these two expressions contain fractions. However, look at the numerator in the second expression, 1 minus 3u. This is similar to the situation we had in, should be B. B of example 1. The y was on the second part, first there was a constant, then there was a variable. Over here in the numerator we have the constant, then we have the variable. So what we're allowed to do is we can rewrite this, and we can change this to minus 3u plus 1 all over 5. And now what we can do is we can start looking at how this expression is built up. Investigating, we know that there's addition. We know that there's multiplication. We know that there is division. Looking at the order, remember, there is always implied brackets in the numerator of a fraction. So therefore, we first have to look at what's inside the brackets, multiplication and addition. In this case, addition comes first. In this case, multiplication becomes first. Addition comes second. And then finally, outside the brackets, we can do our division. Alright, let's construct the flowchart. Starting off, we have u. Next, it's going to become 3u. After which, it's going to become minus 3u plus 1. And then finally, minus 3u plus 1 all over 5. Looking at its construction, u becomes minus 3u by timesing it by negative 3. Minus 3u becomes minus 3u plus 1 by giving it 1. And then dividing it by 5. Next, we reverse. Rather than divide by 5, we times by 5. Rather than adding 1, we take 1. And rather than timesing by minus 3, we divide by negative 3. And thus concludes our construction of our flowchart. Moving down, we increase the degree of complexity here. We have 3z minus 5 all over 4 plus 8. Let's have a look at our operations we have. There's an addition of 8. We have a take 5. We have a times 3. We have a divide 4. Looking at the order of the operations, remember, there are always implied brackets in the numerator of a fraction. So that means we first have to do the brackets here. We have times and we have take, so first we do the multiplication, then we do the subtraction. Outside of the brackets, we have a division and we have an addition. Division takes precedence, so it's third, and then addition comes last. Awesome. Let's build this up. Starting off, a variable that we're working with is z. Z is going to turn into 3z, because we multiply it by 3. Next, z is going to turn into 3z take 5 because we take 5. Next, z is going, or 3z take 5 is going to turn into 3z take 5 over 4 because we're going to divide by 4. And then, if I can fit this in, 3z take 5 divided by 4 is going to turn into 3z take 5 divided by 4 plus 8 because we add 8 to it at the end. Probably should have gone across the page, but that's okay. Destructing this statement, rather than adding 8 we take 8, rather than dividing by 4 we times by 4, rather than taking 5 we add 5, and rather than timesing by 3 we divide by 3. And thus we conclude the construction of our flowchart. Alright, moving down. We have some extension, radicals and squares. What do we do when we're dealing with radicals and squares in flowcharts? Starting off, let's just draw our expression and see what we have. I'm going to draw it in the middle to space it out a little bit better. Looking at our operations, we have addition of 9. We have division of 3. We have subtraction of 5. And we have times by 3. Okay, and the final one, we have the x squared here. This is square. Square the x. So we have 1, 2, 3, 4, 5 different operations. Now again, we need to recall there is implied brackets in the numerator of a fraction. So because of that, we're going to have to deal with all of the operations that are happening up in this bracket first. Now looking at this, we have square, we have subtraction, and we have multiplication. Going up, recall that exponents come first, so our squaring operation is an exponent of 2. That comes after brackets. Then we can do division and multiplication, and then finally we can do addition and subtraction. So the order in which we're going to do this is, firstly we're going to take care of that squaring operation. Then we're going to take care of that times, then we're going to take care of that subtraction. After which we have division and addition. Next we will do the division as the fourth operation, and the final operation will be addition. Alright, let's build this up. Starting off, we start with x. From the x is going to turn into an x squared. This occurs because we employ the squaring operation. After this, x squared is going to turn into a 3x squared. This occurs because we're going to multiply by 3. After this, 3x squared is going to turn into 3x squared take 5, because we're taking 5. Nearly there. We turn it into a fraction. 3x squared take 5 becomes 3x squared take 5 over 3. Why? Because we divide it by 3. And then bringing it home. 3x squared take 5 over 3 becomes 3x squared take 5 over 3 plus 9, because we're going to add 9. So there's our construction statement. Next, let's look for destruction. How do we unwind the right and turn it back into just an x on the left? Rather than taking 9, we Rather than adding 9, we take 9. Rather than dividing by 3, we times by 3. Rather than taking 5, we add 5. Rather than timesing 3, we divide by 3. And here's a new one. Rather than squaring the value of x, we're going to square root the value of x. So the opposite of square is square root. And thus we construct a flowchart. Let's move along. We want to construct the flowchart for this example over here. The square root of x take 1 plus 3 all over 2. So we're seeing square root symbols here. Again, let's have a look at how this is built up. We might take a bit more space. Starting out, we have x take 1, and then we have a plus 3, and that's all over 2. Let's have a look at how this expression is constructed. We have a divide by 2. We have an addition of 3. We have a square root. And then we have a take 1. So we have 4 different operations here. Now let's have a think about how all of these go together. Firstly, we have addition, we have divide, we have take 1, and we have square root. Now if we go up, we notice that there is no square root in our BEDMAS diagram at all. But interestingly enough, the square root lies between the bracket and the exponent. Well, technically it is a bracket and it is an exponent as well. So what we're going to find is that when we have a square root symbol on anything, everything inside the square root has implied brackets. So the first thing we have to do is we have to evaluate what's inside the brackets. So that's the take 1. Next, we can deal with the square root. That's going to be our second operation. Our third operation is going to be our division, and our fourth operation is going to be our add 3. Putting this together, we're going to start off with x. And we're going to transform x into an x take 1. After which we're going to do our square root operation, which is going to transform x take 1 into the square root of x take 1. Next operation, it will be the square root of take 1, and we're going to add 3 to that. And then finishing this all off, square root of x take 1 plus 3 is going to be divided by 2 to give us square root of x take 1 plus 3 all divided by 2. There's our construction. Let's look at our destruction. Rather than dividing by 2, we times by 2. Rather than adding 3, we take 3. Rather than applying a square root, we do the reverse operation of applying a square. And then to reverse the take 1, we just add 1. And therefore, we discover how we can build the expression the square root of x take 1 plus 3 all over 2, starting from the value of x. So in summary, what we set out to learn in this lesson was how we can build expressions and model them using construction and destruction flowcharts.